Welcome back to Topic 11 for Algebra 2, Systems of Equations. In this video, we're going to learn how to solve a system of linear equations by graphing, substitution, and elimination. We're first going to start off with graphing. Here we're asked to solve the linear system by graphing. Our two equations are y equals x plus 2 and negative 3x plus y equals negative 2. Now the first thing that we really want to do is get both equations into slope-intercept form. This just makes it easier to graph on a coordinate grid. Notice how our first equation, y equals x plus 2, is already in slope-intercept form, so we can graph it. Our y-intercept is 2, and then our slope is really 1 over 1, so we're going to rise 1, run 1, rise 1, run 1. And if we want to extend our graph in the other direction, fall 1 to the left 1, fall 1 to the left, fall 1 to the left, etc., etc. Now our next equation is actually in what is called standard form. So we have negative 3x plus y equals negative 2. Instead, what we're going to do here is we're going to erase this. There we go. We're going to isolate our y. So instead we see this negative 3x. We're going to add 3x to both sides. On the left side it reduces, and we're just left with y on the left side. So this is the same thing as negative 2 plus 3x. However, if we want it to look more in slope-intercept form, remember we keep the sign that's in front of my term. Together, this is the same thing as y equals 3x minus 2. So that is my second equation. Now I can graph this, y-intercept of negative 2, and our slope is 3 over 1, so rise 3 over 1, rise 3 over 1, or fall 3 to the left 1. Notice how my two lines intersect at this one point, which is 2, 4. So this is my solution. So again, 2 would be my x variable, and then 4 would be my y variable. Let's try another example. In example 2, we're going to solve the linear system by graphing, but here both of our equations are in standard form, so we need to convert them to slope-intercept form. Let me rewrite my example up here. So we have x minus y equals 5. We're going to subtract x from both sides, and we get negative y equals, if we write it in slope-intercept form, negative x plus 5. But here this is really a negative 1y, and we want just a positive y. So we're going to divide both sides by negative 1. And that means every single term by negative 1. You get a negative 1, you get a negative 1, everybody gets a negative 1. We're going to be left with y equals negative 1x divided by negative 1 is just positive x, and 5 divided by negative 1 is negative 5. So that is my first equation that we can graph. Y-intercept of negative 5, and my slope is 1 over 1. So rise 1, run 1, etc., etc. Now our next equation, we have 3x plus y equals 3. We're going to subtract, similar to what we did in example 1, subtract 3x from both sides, and our y is already isolated here, so we just get negative 3x plus 3, and that is my second equation. So again, y-intercept of positive 3, but my slope is negative 3 over 1, so we're going to go down 3, 1, 2, 3, and to the right 1. So we have a negative slope, 1, 2, 3, or up 3 and to the left 1. Now here, my point intersects at 2, negative 3, so that is my solution. Now another way that we could solve a linear system is by substitution. So substitution, how it's easiest to do is to isolate one variable and then plug that into the next equation. So here we have my variable y is already isolated, and it's equivalent to 2x plus 5. Now in my second equation, I already have a y. 3x plus y equals 10, so I'm going to plug this entire quantity wherever I see a y in my other equation. So I will end up getting 3x plus 2x plus 5, that was my y value from the previous equation, equals 10. Now I can combine my like terms. On the left side I have 3x and 2x, which gives me 5x, plus 5 equals 10. Now I have a two-step equation. I can subtract 5 from both sides and get 5x equals 5. Now I have 5 times x, apply the inverse, and divide both sides by positive 5. On the left side it reduces to 1, so I get x equals positive 1. And that is my x-coordinate. Now in order to get my y-coordinate, I have to plug back in to find it. Now you could plug this back into either equation, but I think the first one would be a little bit easier because our y is already isolated. So we have y equals 2x plus 5, but instead x, I'm going to plug in a 1 from right here. Add 5. So y equals 2 plus 5, or 7. So in other words, my solution is 1, 7. That's on the graph where they would intersect. In my next example, I'm also asked to solve the linear system by substitution. However, in these two problems, they're both written in standard form. So, what's an easiest way to isolate a variable? I think it would probably be easiest to isolate this x because it's already positive. So we can rewrite this. We can rewrite this equation to be x equals, if we add y on both sides, 3 plus y, or y plus 3, same exact thing. Now I can plug that back in to my next equation, wherever I see an x. So I will get 3 plus y plus 2y equals 6. Now I can combine my like terms. Y plus 2y gives me 3y, so I have 3 plus 3y equals 6. From this two-step equation, I can subtract 3 on both sides and get 3y equals 6 minus 3, or 3. Divide both sides by 3, and y should give me positive 1. So again, now I have my y variable, but I still need to figure out my x variable. So I need to plug back in to find x. I always like to plug back into one of the original equations because it's easier just to make sure that you did the math correctly and you didn't mess up when you were translating the equation. So let's choose this first equation here. We're going to have x minus 1 should give us 3. Add 1 to both sides, and x should equal 4. So my solution is 4, 1. There you go. Now let's move on to, last but not least, elimination. So in this example, example 5, we're asked to solve the linear system by elimination. In this case, we're just going to add vertically. That's all elimination is. So I'm going to add each column. 2x plus 6x gives us 8x. Again, we're adding our like terms. Positive 5y minus 5y adds to 0. And 17 plus a negative 9 gives us positive 8. So now we can solve this as a one-step equation. We're going to divide both sides by 8 and get x equals 1. Now we're going to use substitution. So we can plug back into either equation in order to find y. Let's do the first one. So we have 2 times our 1 from up here plus 5y equals 17. 2 times 1 is 2 plus 5y equals 17. We're going to subtract 2 on both sides, and we get 5y equals 15. Divide both sides by 5, and we get y equals 3. So my solution is 1, 3. Perfect. Let's move on to our next example. Here we have negative 2x plus 15y equals negative 32, and 7x minus 5y equals 17. Now if we looked vertically, we would not be able to reduce or eliminate any specific variable in order to isolate the other. Now what we have to do is we have to manipulate. Well, we can look at our negative 2x and our positive 7x. There it would take a little bit more doing in order to eliminate that x variable. However, in our y column, we have positive 15y and negative 5y. So our goal here is to get positive 15y and negative 15y. So that way they can reduce. So what do we need to do to the second equation in order to get negative 15y? We're going to multiply the entire bottom equation by positive 3. Now here, you're going to use the distributive property to make sure you multiply to every single term. So nothing's changing in our first equation, so I'm just going to rewrite it. Negative 2x plus 15y equals negative 32. Our bottom equation, if we multiply 3 times 7x, gives us positive 21x. 3 times negative 5y gives us negative 15y. And 3 times 17 gives us 51. Now we're going to add. Negative 2x plus 21x gives us 19x. 15y minus 15y gives us 0. And negative 32 plus 51 gives us positive 19. Divide by 19 on both sides, and we get x equals 1. Now again, we still need to substitute in order to find y, so let's substitute back into an original equation. So let's say we have negative 2 times our 1 is going to go in for x plus 15y equals negative 32. So we have negative 2 plus 15y equals negative 32. Add 2 on both sides, and we get 15y equals negative 30. Now we can divide both sides by 15, and we get y equals negative 2. So our solution here our x-coordinate is 1 and our y-coordinate is negative 2. Perfect. Moving on to our last example, example number 7, we're going to solve the linear system also by using elimination. However, notice how when we want to eliminate either our x variable or our y variable, there isn't an easy number that we can multiply just one equation by in order to eliminate one of the variables. Instead, we need to multiply both equations. So here's where it's up to you. You can choose which variable you would like to eliminate, either the x or the y. Here, I'm going to say my goal is to eliminate the y variable. So I need to get a common multiple, preferably the least common multiple, and have them be inverses so that when I add them, they reduce to 0. How I'm going to do this is the first equation. Let's say the least common multiple of 2y and 3y. We want to get positive 6y and negative 6y. So in order to get positive 6y in the numerator, I'm going to multiply that entire equation by positive 3. In order to get negative 6y in the denominator, what I'm going to do is I'm going to multiply that entire row by negative 2. Now let me distribute and rewrite my equation over here on the left-hand side. 3 times 3x gives me 9x. 3 times 2y gives me positive 6y. 3 times 1 gives me positive 3. For the negative 2, I'm going to multiply negative 2 times 4x gives me negative 8x. Negative 2 times 3y gives me negative 6y. Negative 2 times negative 2 equals positive 4. And again, what I'm doing here is I am adding. So 9x plus a negative 8x gives me just x. Positive 6y plus a negative 6y reduces to 0. And 3 plus 4 gives me 7. So here I actually don't need to isolate my variable x, it's already isolated. However, I still need to solve for y. So I can plug back into an original equation. Let's do 3 times 7, that is my x, plus 2y equals 1. So I have 21 plus 2y equals 1. Subtract 21 from both sides, and I get 2y equals negative 20. Now we can divide both sides by positive 2 to isolate that y, and y equals negative 10. So my solution here in x comma y is 7 comma negative 10. And oops. There we go. Thank you for watching Algebra 2, Topic 11 on solving systems of equations.